All right, so we're going to continue with learning about naming rules. Okay, we've done ionic compounds. We spent the past two lessons on ionic. The first lesson is just to name basic ionic compounds. Cation, anion, that's it. And with IDE. And then last class, we talked about polyatomic ions and multivalent metals. If you're multivalent, you have more than one possible charge. And you have to denote that using a Roman numeral. Polyatomic ions, well, there's a list of polyatomic ions that you don't have to memorize, but you do have to recognize one when you see one, and you have a data sheet for that. You have a table of polyatomic ions with their name, their formula, and their charge. Okay, make sure you use that. So today, we're going to talk not about ionic, but molecular compounds, the other type of compounds. Okay, so this is strictly just covalent bonding. We're going to review what that is. And then we're going to talk about the naming rules for molecular compounds, which is different from ionic compound. Please don't get them confused. That's one of the biggest mistakes. People use the wrong rules. Use the molecular compound rule for ionic and ionic for molecular. Okay, so let's start. First of all, I just want to say that I really hate the government. The Canadian government is terrible. The American is even worse, but the Canadian one, like Trudeau doesn't really do anything. He promises a lot of things. He says all the right things. You know, he checks all the right boxes to get votes, and then once he's in office, whoops, we're not doing it. And this is what I'm talking about. This is one of the issues I have with the government, because they don't regulate big companies, and those companies get away with a lot of stuff. Like they use a lot of toxic compounds, and yet the government does nothing. Like dihydrogen monoxide, DHMO, that's the shorter form. So this chemical killed millions of lives. The coronavirus killed millions of lives, and so we make a big deal about that, and rightfully so. But this is given no attention. The government never even mentioned this. It wasn't on the news. During the election last year, no party member talked about this at all. But look, it's an acid rain. It is a greenhouse gas for all those people that care about climate change, like Elizabeth May, the Green Party, hello, NDP. They talk about climate change a lot, and yet no one addresses the biggest greenhouse gas. It can cause severe burns if it comes into contact with your skin. It's inside tumors of terminal cancer patients. Okay? If you expose the solid form of this to your tissue for long enough, it will cause permanent damage. And you can get hooked up on this. And if you do, withdrawal is lethal. That means you can't quit. Like cigarettes, you can quit. Marijuana, like even cocaine, meth, you can quit. There's withdrawal symptom that sucks, but you can get rehab and you can come out clean. But this, once you're hooked, you can't wean off of it. And despite all the danger, where do you see this? Okay, DMHO is used everywhere. So it's a solvent used for industries. It's in nuclear power plants. It's a fire retardant. That means it's used by the fire department. They use DMHO to distribute pesticides for farming. It's inside of many food products. It's inside of your food, people. Okay, they don't label GMOs, and people really get pissed about that. They don't label this. This is in food, but people don't tell you. And also companies, where do they dump this? Into the lakes and the oceans. No regulations. And so basically all the lakes in the world have been contaminated with this horrifying substance. Yeah, no, something needs to be addressed. The government needs to be accounted for. And we need to I think there's already a petition online that you can sign to basically tell the government, like, hey man, Trudeau, you want to win the next election? Yeah, no, not just COVID, but this. Okay, I don't know what you're talking about in the comment there, but yeah, this is a terrifying substance, dihydrogen monoxide, DMHO, that needs to be banned. Stop putting chemicals into our food. All right, so that's my little rant, and I'm done. Okay, DMHO is a molecular compound. Yeah, well, dihydrogen monoxide. Di means two, mono means one. So two hydrogens, one water. DMHO or H2O. That's correct. Anyway, basically, that's the gist of the lesson. We're going to learn about molecular compounds. We're going to learn how to name them, like H2O. And we're going to learn why things undergo covalent bonding. Okay, so you have to understand that these are now molecular compounds. Okay, it is different from ionic compounds. Molecular compounds are made up of nonmetals bonded to other nonmetals. Okay, and they can have different formulas, but with the same number of or same type of atoms, I should say. One example is nitrous oxide, N2O, kind of like H2O, but instead of H you have N. Well, what is that? That's laughing gas. People in the past, dentists, used to give this to patients as an anesthetic. It calms them, relaxes them, and puts them to sleep. Okay, it's colorless, kind of smells sweet. Nitrogen dioxide, NO2, so one N and two O's. Yeah, that's also made up of nitrogen and oxygen, but this is a toxic gas. It's reddish brown, and polluted cities often has this. If you see like a brown haze over your city, this is why, because that city has been polluted with nitrogen dioxide. And if you look at the picture, oh, look, that's the CN Tower, isn't it? Yeah, that's us. Okay, so many cities are polluted with this. These are completely different stuff. They're both made up of nitrogen and oxygen, covalently bonded to each other, and they're both gases, and yet they are different. Okay, different properties. So therefore, we need to name them differently. Okay, so comments. They say that DHMO is another name for water. Yeah, really? I never knew that. DHMO is water? Nuh-uh. The water is not dangerous, though. Okay, there's a link, but like I don't have time to click that. I'll click it later. But look, just look at the negative effects of DMHO and tell me that water does the same thing. Like, you see what I mean? Okay, I guess this is all true for water. Yeah, no, this is also all true for water, but it has a dangerous sounding name. You see what I mean? DMHO, that sounds like something made in a lab. Look at these sciencey words. That must be dangerous. That's how people think. Like, there's chemicals in our food. Water is a chemical. We're not wrong. Dihydrogen monoxide, that's the name of that chemical. So, you know, there's chemicals in our food, and that's bad. Okay, that's what I'm trying to get across here. Okay, so back to molecular compounds. Water's found everything. It's just a hoax. I mean, it's better safe than sorry, right? Like, do you really want to risk your life eating DMHO where it could actually kill you? No, we should ban it entirely just in case. You see what I'm not getting my kids to consume DMHO. I don't care what the government says. Like, I don't trust big pharma. Like, I don't trust chemicals. My kids are not having DMHO. Okay, so anyway, molecular compounds. So what is a molecular compound? Well, these are atoms of nonmetals joined together via covalent bonds, and they form molecules. Okay, notice the difference between the pictures. Molecular compound versus ionic. Ionic is a crystal. They are made up of positive and negative ions attracted to each other, Romeo and Juliet style. They kind of group together because plus attracts negative into a giant crystal that can grow really, really big. Okay, an ionic compound can be really large, but molecular compounds, they have a particular size. That's it. If you add more stuff to it, it becomes a different compound. So these are molecules joined together via covalent bonds. Okay, so here is what covalent bonding is about. Nonmetals they need to gain electrons, okay? Because if you just look at nonmetals, they're found on the right side of the periodic table, meaning that they already have a load of valence electrons. Like fluorine here, it has 7, it wants 8, so I just need one more. The other fluorine has 7 and it wants 8, so they both want an electron from each other. And there's no way they're going to give each other an electron. So no, you take it from a dead body. That's kind of the deal here. So what do? They both want to take an electron from each other. Well, sharing is caring. We learned that from Care Bears. So they actually share their lonely electron with each other. So now they both have ownership of that electron. So they come together like that. So their atoms overlap. And those two electrons are now shared between those two atoms. So if you count them, everybody now has 8 valence electrons. So those two right there, the flashing ones, those are the shared electrons. Okay, so this sharing of electrons is what causes covalent bonding. Okay, notice that this is different from ionic. Ionic is I take an electron from you, and you're happy to give it to me. So positive and negative charges form, they attract. This one, nobody wants to give up an electron. Instead, you know what? Let's just share. Okay, does that make sense? So here's the difference. Non-metal nonmetals, they share electrons to form covalent bond. Metal nonmetals, they give electrons. More specifically, metals give electrons to nonmetals, so they form ionic bonds. Okay, do we have any questions regarding covalent bonding? Damn, that's a lot of info. So you're telling me that the DMHO thing is a hoax. Ban dihydrogen monoxide. I could get behind that. This 14-year-old student started a petition to ban DHMO as part of How Gullible Are We? Yeah, of course. How gullible are we? Like, just believe what the government says. So DMHO definitely needs to be banned, right, guys? Okay. So a covalent bond is different from a molecule. This is the bond that we're talking about. The bond that holds the molecules together. Just like ionic bonds and ionic compounds, it's a little bit different. Okay. Also, covalent bonds can form between the same atoms, because if you're both non-metals like H and F, you can just bond with itself. H bonds with H, F bonds with F, and that will be a sharing of electrons between two different atoms. And actually, if you do that, we have a diatomic molecule. Di means two. Okay, diatomic, 2 atoms together. That simply means this covalent bond has 2 atoms. It doesn't have to be 2. It can be 3, like water, H2O. There are 3 atoms in here, so that would not be diatomic. So HF, one of the most deadliest substances in the world, that is diatomic. Okay, and also on this slide, you have the diatomic elements. This is, again, different from diatomic molecules. Elements are just one type of atom. If you look on the periodic table, there are some special ones that never wants to be lonely, like hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All of these, the ones I listed here, they will always form pairs. Okay, you will never see H just by itself. It always comes in H2. Nitrogen is never just N, it is N2, because all of these seeks to have more electrons so that they will bond with itself to form a diatomic element. You need to have these memorized. These 7 of them are the diatomic ones: H2, N2, O2, F2, Cl2, Br2, and I2. They always come in 2s. Never write them as 1s unless it is an ion, which these are not. Okay, don't worry about the phosphorus and the sulfur in yellow. Don't worry about those. We only care about the special 7. Okay, and when I was in high school, I was asked to memorize these. That sucked. Okay, I had to figure out a way to just have it memorized, but then Later on, somebody told me that if you just look at the periodic table in purple, they form a number 7 on the right side of the periodic table. I'm like, what? They do. Nitrogen, oxygen, fluorine, and then you go down, chlorine, bromine, iodine, and then of course hydrogen is all the way on the other side. So those 7 elements actually form a number 7 on the periodic table. Okay, so that's an easy way of remembering which ones. So you do need to know which ones are diatomic elements, and please make sure you don't forget that these are diatomic, because you will get a question really wrong if you forget that. Okay, so wait. Comments. Maybe he's just joking. Oh no, I'm dead serious, people. Okay, so we're gonna learn naming of these compounds. There are some that they do have a proper name. It's just weird calling it that. So they go by their common names. For example, water is H2O. Like, nobody calls it by its scientific name, dihydrogen monoxide. We call it water. Everybody knows what water is, but not everyone knows about dihydrogen monoxide. You see what I'm saying? Hence, a lot of people can be fooled by their name. Like that ad I showed you earlier. Dihydrogen monoxide is just the IUPAC name for water. Ammonia is NH3. No one calls it by its actual name, nitrogen trihydride. I've literally heard that like 0 times. Okay, but we all know ammonia is. You probably have that at home. And methane is natural gas. Again, we call it either methane or natural gas, CH4. We don't ever call it by the actual IUPAC name. So these 3, okay, you need to know their common names, because they're so common, we just don't call them by their IUPAC names anymore, which is probably a good thing. So basically, DMHO is water. Oh, damn. Okay, that makes a lot of sense. Yes. Yeah. No. Oh, yeah. So it is a hoax, like some of you are saying. So my bad. I learned something today. Yeah. So DMHO, it turns out it's water. So I guess we can all learn something from that. It's not reasonable to just fear chemicals. Okay. Chemophobia is a thing. People fear the idea of chemicals. There's chemicals in my food. If you think about it, everything in this world is a chemical, because everything is made up of atoms, hence chemistry. Okay, water is a chemical. Sugar is a chemical. Salt is a chemical. Vitamins are chemicals. In fact, vitamins are acids. Okay, and acids sound terrible. The DNA is a chemical. Your cells are full of chemicals. Everything in this world is a chemical. So just because something has chemicals in it, well, it should, doesn't make it bad. And just because something sounds horrifying, dihydrogen monoxide, or I don't know, sucrose, or potassium cyanide, that's actually deadly. Just because something sounds deadly doesn't mean it is deadly. Some things are actually deadly, so that's why you need to learn the science before you jump to conclusions. So that's an issue that most people have, because in grade 10 they stop taking science afterwards, and they totally forget everything they learned, and that's how the media lies to you, because people don't remember their basic science education, which I'm very sad to say that the science education ends in grade 10. Which is why in grade 10, I'm trying to get everyone here to become scientifically literate. That means you can tell facts from crap. Okay, that's all I want. You don't have to remember any materials that we learn after the test if you're not pursuing science, but just know how to think critically. Okay, not to fear everything that sounds weird. Look into it first, research what is it, and look at who's speaking. If it comes from a celebrity with no science background, or it comes from some random YouTuber that they cite different websites and other videos, yeah, I probably don't believe them. Okay, if you see it from like prestigious scientists, from textbook university professors, actual researchers, yeah, they might have something important to say. Okay, if it comes from like a corporation or a company that obviously has a stake in something, yeah, I probably don't believe them. If the coal company, the fossil fuels industry says that coal is clean, take that with a grain of salt. I'm not saying they're wrong. Research it, because if you just believe them, just think about it. They're trying to sell coal. Of course, they're going to say it's clean. You see what I mean? Yeah, all those facts about water I just showed you, they're all true. You have access to my notes. You're welcome to go back. I didn't tell you a single lie in those 2 slides. They're all true. Water is found in acid rain. In fact, that's what rain is. Water is found in tumors because your cells are full of water. Okay, water is used as a fire retardant. Duh, water puts out fire, right? It's used as a chemical solvent. It's used in nuclear power plants. Yep, that's how nuclear power plants work. They heat up water to turn a turbine. Okay, withdrawal can be lethal. Yeah, try not to drink water and see what happens. You're gonna die. Prolonged exposure to its solid form will hurt you. Yeah, just hold ice for an hour and see what happens. You see what I mean? All of these are actually true. Water kills a lot of people. A lot of people drown. Okay, millions have drowned in the history of humanity. So all of these are true, but the fact that DMHO is dangerous and should be banned, that's a lie. So you can speak a lie by only telling truths. Okay, that's how a lot of the time politicians and media work. They never actually lie to you, but they only told you some facts, but not the others, so that your perspective is skewed and biased towards whatever they want you to believe. So again, that's why it's there, just to get you guys to think about what you hear and just don't believe everything. Okay, so let's actually start naming compounds covalently, of course. Ionic compounds, they can only be combined in very specific ways. You have to balance their charge. Okay, like sodium and oxygen. Sodium is 1+, oxygen is 2-. You got to have 2 sodiums and 1 oxygen. No choice. But molecular compounds, you do have a choice. Carbon and oxygen, they can bond in many ways, and here are 2. On the left, you have CO2, carbon dioxide, something we're very familiar with. On the right side, you have CO, also carbon and oxygen, but way more deadly, carbon monoxide. Okay, carbon dioxide is something that you breathe out. It is inside of your blood. In fact, you cannot live without carbon dioxide. People say that carbon dioxide is a waste. Sure, we don't need it, but you can't not have it. Okay, in fact, if your body is deficient in carbon dioxide, you will pass out. Okay, so carbon dioxide is a greenhouse gas. It's a thing that we release into the air after we burn fossil fuels. We know a lot about carbon dioxide. Plants need it to grow. Carbon monoxide is a colorless, odorless, deadly gas that will kill you without you knowing it. So yeah, they're different. If you're breathing carbon dioxide, the only issue is you're not breathing oxygen, and if you accumulate enough carbon dioxide, you change the acidity of your blood, but that takes a while. But carbon monoxide, you breathe it goodbye. So it is very important to distinguish which is which. Right? That's why carbon dioxide, not just carbon oxide. If you just say carbon oxide, yeah, you're not telling me which one. Okay, so that's where prefixes come in. A prefix is a couple of letters before a word that gives it meaning. Okay, like increase, decrease. Increase means to go up, decrease, de means to go down. That's a prefix. Now, we have some very specific prefixes in chemistry to denote how many atoms we have. And here is a wonderful table of prefixes. Okay, so 1, if you have 1 of something, is mono. Like monochromatic, 1 color. Monotone, you talk like this and you are extremely boring and puts people to sleep. That is monotone voice. That sucks. Okay, that's mono. Di means two. Like, yeah, what's di? I can't think of any word that uses di, but is not scientific. But just take my word for it. Di definitely means two. A double. I guess that's where it comes from. Yeah, I can only think of science word that starts with di, meaning two. Tri, oh, that's an easy one. Three triangles, a tricycle, to triple, and three. Now here's where it gets messed up. Tetra. Yeah, tetra is not a word that you hear very often in math. A tetrahedral is a four-sided shape. So tetra is four. You just have to know it. Penta is easy. The pentagon, a five-sided shape in the building in the United States. Pentakill, if you play League of Legends, he killed 5 enemy players. Penta means 5. Okay, hexa, a hexagon. That means 6, and there's X in it. The word 6 has X in it. And then hepta, octa, nona, deca, 7, 8, 9, 10. Hepta, that's kind of hard to remember. That's 7. Octa is easy. Octopus, a creature with 8 tentacles. An octagon is an 8-sided shape. Nona, that looks like the word 9. Deca, well, a decade, it's 10 years. A decimeter is 10 meters. Okay, in fact, that's why we call it a decimeter. Decimals, using 1/10 of a number. Okay, so that's 10. You need to know these prefixes. You have to know which corresponds to which number. And yeah, that's gonna suck, but it's like memorizing 1 to 10, how to count from 1 to 10 in another language. This is a language of science. Okay, so you have to add a prefix to denote how many atoms you have. But the prefixes have special rules. Yeah, I know, this sucks. If you have one of something, you don't actually say it if it's the first element. Like carbon dioxide, CO2, there's one carbon. You don't say monocarbon dioxide. Okay, that's kind of redundant. You don't have to say it. Just carbon is fine. If you just say carbon, we assume it's 1. Just like in math class, 1x, you don't have to write 1. It's just x. You see what I mean? So carbon dioxide. But if it comes second, if it's the second element, CO, then you have to say it. Monoxide, yeah, because it comes second. Carbon monoxide, you have to say the mono. Okay? Second element, if it's 1, you have to say the mono. The first one, you don't. Here's another rule. Sometimes when you get 2 vowels together, a vowel is A, E, I, O, U. Like mono ends with O. Oxide starts with O. Monoxide sounds awkward. So we just drop 1, monoxide. Okay, tetraoxide sounds awkward. So tetroxide, you drop the A. Pentaoxide is awkward, so pentoxide. Yeah, don't blame me. I didn't come up with these rules. IUPAC did. If you're going to hate this, write an angry email to IUPAC, explain to them how much they suck and how much you hate their system. But don't shoot the messenger. I'm just teaching you the system here. So yeah, you got to remember these 2 rules. The first compound, if it's a 1, don't write the mono. And also, if you see an oxide, yeah, you might have to drop a letter so that you don't have double vowels. Let's do some examples. P2O3. Well, wait, did I skip a slide? Okay, P2. P is phosphorus. 2, there's 2 of them, di. Okay. O is oxide, oxygen. You have to change the name to IDE. 3 is tri. Okay. Okay, put them together. 2 phosphoruses, 3 oxygens, so diphosphorus trioxide. Done. No Roman numerals, none of that garbage, but you do have to tell me how many phosphoruses, how many oxides. Okay, is that clear, everybody? Feel like this is fairly clear? Okay, well, let us do more practice. But first, I need you to like take the oath. Okay. Now we're not in physical classroom right now, and I don't want all of you to turn on your mic. So just stay with me without the mic on. Everyone take the oath. Okay. So I don't know how you want to do this. Put your hand on some holy book, or if you don't have a holy, put it like this on your heart. And you solemnly swear that I, insert your own name, hereby solemnly swear to use prefixes such as mono, di, tri, like the ones we just learned, to name only molecular compounds and never ionic compounds. Okay. Failure to act in accordance to this oath will result in an automatic grade of 0 on any affiliated questions. I waive my privileges to any possibility of part marks and fully accept the consequences. Okay? And end oath. Do you get that? You never use these prefixes, mono, di, tri, on ionic compounds, the previous two lessons. You only use them if the compound is molecular. That means it's a covalent bond. That is something that I've seen so many times students get wrong, so I came up with this. Okay, take the oath, remember that you did this, and slap yourself every time you make that mistake. Please, step 1, you determine whether this is ionic or molecular, and then you proceed to solve the problem. You gotta know whether it is ionic or molecular first. Okay, and then you name the first element, you name the second element. That's what we learned for ionic. Change the end into IDE, and then add prefixes only if they are molecular. If they're ionic, you don't add them, and you're done. If you're multivalent, you put the Roman numerals. Okay, so we've learned many rules up to now. Individually, they're all very simple, but combined together, they can be confusing. So let's do more examples. By the way, we're practicing molecular compounds only. And then at the end of this class, we're going to practice a mix of everything. So then you have to be very careful. So right now, everybody's molecular. So SF6. Okay, so let's quickly into the chat. What is the name of SF6? Okay, you're gonna, well, you probably don't need a periodic table if you know what S is and you know what F is. If you don't, look it up, count how many, and then write the name. Go. I'll take it up in like 10 seconds. Both of you are right, but both of you spelled fluoride wrong. U before O. Oh, never mind. The timer did not spell it wrong. I read it wrong. Yeah, fluoride. F-L-U-O, not O-U. F-L-O-U-R, that's flour. That's the thing you bake with. So I'm seeing sulfur hexafluoride. I'm seeing a lot of that, which is okay. Okay, I think you're getting this. S is sulfur. Prefix is 1, mono, but you don't really need mono for the first one. In fact, please don't have mono for the first one. Okay, there's only one right answer. If you have mono, that's a wrong answer. F is fluoride. Make sure you spell that right. 6 is hexa. Put them together. 1 sulfur, 6 fluoride. So sulfur, hexafluoride. Okay. In fact, I think naming molecular compounds is easier than naming ionic compounds. You just have this one rule. That's it. It's just that you mix it up. That's the problem. So write the name of no. Okay, NO. And please go ahead. That one, there's a little trap in here. Okay, I'm seeing different answers. Huh. Okay, so some of you are following the rules, some of you are not. How are you getting these? Okay, nitrogen, N is nitrogen. Don't change it, it's just nitrogen. One nitrogen, mono. Again, you don't need mono for the first one. O, that's oxide. How many? One, mono. But you do need the mono for the second one. So you can't cross that out. So put it together. Nitrogen monoxide. You drop an O, not monoxide, double O's. That's bad for some reason. Just monoxide. Okay, that's it. Nitrogen monoxide. Okay, does that make sense? We're good? Nitric oxide. Yeah, about nitric oxide. That is not a proper IUPAC name, but we do refer to NO as nitric oxide. Okay, actually, all N and O's are nitric oxide. N2O, NO2, N2O5, NO. All of these, as long as you only have nitrogen and oxygen, we call them nitric oxides as a general blanket term. But this specifically, the name is not nitric oxide. It's like your name is not human. Okay, you have a name. And so it's not mono oxide. Please make sure you drop one of the O's. Okay, we're good. We're good. All right, so we're almost finished. Take a few minutes to finish this one. Notice some of these are quite simple, like H2O. You take your pick. You can say water or the long version of that. Fill this out. All of these are molecular. Okay, I'm telling you right now, all of these are molecular. So do it the molecular way. Let's practice that. And in 5 minutes, I am going to take this up. So I'm going to drink some water and relax. I've been too excited in this lesson. Hydrochloric acid. Well, I'm certainly not going to say you're wrong. It's just I never taught you how to name acids yet. If you know how to name it, that's good for you. But I was looking for the normal way of naming, not the acid way. But if you write hydrochloric acid, there is a small detail that tells you whether it's an acid or not. But yeah, it's technically correct. The hydrogen chloride is also technically correct. And I say technically because you're supposed to have the mono, hydrogen monochloride, but, okay, here's the but, hydrogen chloride has become so common, they made it correct. You see what I mean? Yes, monochloride does sound ugly. So we call it hydrogen chloride. Despite IUPAC, this is a molecular compound. You're supposed to have the mono. But for this instance, we drop the mono. It's like someone called your name wrong. You never bothered to correct them. They just keep calling, and now that becomes your name. Something like that. Like aluminum is supposed to be aluminium. And then somebody dropped the I and spelled it wrong. So now Americans and Canadians call it aluminum. It's technically aluminium. Think about it. All the other metals end with ium, sodium, potassium, chromium, aluminum. No, aluminium. But again, aluminum is the correct spelling because we've embraced that mistake. Okay, I'm just gonna give you like 1 more minute. Okay, are you guys ready to take this up? Because there's another page of practice after this. Starting with the first one, HCl. Technically, the right name is hydrogen monochloride, right? If you want to follow all the IUPAC rules, but if you have hydrochloric acid, that's technically not wrong. That is hydrochloric acid, except that acids all have AQ afterwards, the state symbol, which we'll talk about when we learn about acids, okay? If you write hydrogen chloride without the mono, in this instance, I will give you the marks because this common name has become so common, it's like calling H2O water. It's not the proper IUPAC name, but it is the common name, so that's fine, okay? But for the next one, it has to be phosphorus, pentachloride, 5 chlorines, 1 phosphorus, okay? Oh, damn, I have someone with the answers. Yep. There's one mistake in there. N2O3, the next one. N2, there's 2 of them, dinitrogen. 3 oxygens, trioxide. Okay, next, antimony tribromide. Antimony is Sp. It has a charge of, it makes 3 covalent bonds, 3+. Tribromide, 3 bromines, Br3. Selenium hexafluoride, selenium is Se, hexa meaning 6, fluoride is F. Okay, that one is quite straightforward. As you can see, all you have to do is just read this, find it on the periodic table, put it down, and then read the prefix to determine how many. The name literally tells you how many atoms it has. O2 is just oxygen. Please do not write dioxide. Okay, it's just oxygen. Right? It's not dioxygen, just oxygen. All right, I see you have another answer. Yeah, it's pretty much the same as the previous answer. It's just the same mistake is being made, and I'm getting there soon. NH3, nitrogen trihydride is the actual name, but nobody calls it that. We just say ammonia. So you have to know that ammonia is NH3. Okay, here's the mistake. Helium is He, not He2. Okay, I know I've been trying to stress that the special 7 needs to have diatomic elements. They need 2 atoms. Helium is not one of the special 7. In fact, helium is a noble gas. It is completely unreactive. Helium doesn't react with anything. Okay, so no, it's not going to react with another helium. It already has a full outer shell. It is completely satisfied with its life. So helium is just helium atom, not He2. Please don't make a mistake. He2 is the isotope. No, because helium has 4 things in its nucleus. He4 is the most common one. 2 protons, 2 neutrons, He2, that means you've lost all of your neutrons, you just have 2 protons. That is not very stable. 2 protons will repel each other. So you can't have a nucleus without neutrons if you have 2 protons. So no, He2 is not an isotope. He3 is not 2. Okay. H2O is water, or dihydrogen monoxide, the scary sounding name that actually had a lot of people believe it. That petition online, a lot of people signed it. Okay, that hoax was very successful. A lot of people fell for it to illustrate how you can make anything sound scary without lying. Okay, so that means you have to really do your research. Last one, methane is CH4. And that's one of the common names you just have to know. Natural gas. Okay, that's what we burn to heat our homes. Okay, so that's the answers for the practice. At the end here, okay, we're going to do this together. This is a mix of everything, including ionic. Okay, so this is pulling out all the stops here. Identify as ionic or molecular. It doesn't say name them, does it? Why didn't I say name them? I don't know. First one, A, in the comments, ionic or molecular? I or C, I or M, to make it shorter. Which one is it? M. Okay, that one is molecular. Okay, I guess you didn't have to name these. How do you know it's molecular? I guess that's a more important question. No metal, thank you. You look, 2 nonmetals, there's no way they're giving each other electrons, must be shared. Okay. B, I or C, or I or M. I keep saying M for covalent. I or M, which one? M. Na is sodium. You had the right answer, you changed it to the wrong answer. Sodium is a metal. Yeah, sulfur is a nonmetal, so that's ionic. This is a mistake with C. NH4, that 4 should be a subscript. I think I forgot to subscript that, so please forgive me. Ionic or molecular for C. That's a tough one. Oh, you thought I meant D. Oh, okay. Yeah, we're going down the column here. C. That's a tough one. There's a lot of stuff in there. What is it? Okay, a lot of people are saying molecular. Right? Because look, you don't see any metals in there, do you? Everybody's a nonmetal. So this must mean that it is molecular. No, it's ionic. Okay, here's where your knowledge of polyatomic ions come in. NH4 is a polyatomic ion called ammonium. SO4 is sulfate. Okay, this is ammonium sulfate. 2 polyatomic ions, ammonium is 1+, sulfate is 2-, it's actually ionic. So ionic doesn't necessarily mean metal, non-metal. It's more like positive charge, negative charge. It's just that metals always make a positive charge. Okay, so C is actually ionic. You look at whether you have ions in there. So D, CH4, that one is a simple one. I'm just going to show you molecular. That one, carbon and hydrogen, they're all nonmetals. E, we learned that today it is molecular because we named it sulfur hexafluoride. Sulfur and fluorine, all molecular. Okay, last one. MnCl4 into the chat, please. I or M? I. Okay. Mn is manganese, by the way, not magnesium. But either case, that's a metal. Chlorine is a nonmetal. So that will be an ionic compound. So when you practice, okay, and if you do the quiz or the test, the first thing you do when you're asked to name something is to identify, is this ionic or molecular? Because they have different rules. You see what I mean? Otherwise, you're going to get them confused. Okay, finally, Last one, combined practice problems. Write the names of everybody you see here. It can be ionic, it can be molecular. If it's ionic, it can have a polyatomic ion, it can have a multivalent metal, or both, or none. So good luck. I'll give you around 5 to 10 minutes and post your answers into the chat. And I want to see if someone can get this all correct. I'd be very, very impressed. You do really well in this unit if you can just get all of these correct. Usually that's the biggest hump people have to get over. So go ahead and I'll take it up in around 5 to 10 minutes. Okay, I'm seeing answers. Okay, Tyler, there's one mistake. All right, I don't know why you put a space between the tri and the chloride, and why did you capitalize everything? You have a problem. Gave up. Oh man. Yeah, an F is a tough one. Well, I am. Yeah, you did make a mistake. It's something really small. Monoxide, you don't have that. Okay, well, I'm going to take this up. If you're stuck, you're stuck. I mean, it's somewhere on the periodic table or the data sheet. You just have to find it. First one, NCl3. Well, N is nitrogen. Cl is chlorine, so nitrogen trichloride, that is molecular. Right, so you have to have the tri. Zinc sulfate. Zinc is a metal. Sulfate is a polyatomic ion. That's ionic, so it's just zinc sulfate. Zinc is not multivalent. Zinc is only 2+. You have no choice. Do not give me a Roman numeral, so just zinc sulfate. C, nickel is a metal, and also it is multivalent. So it is nickel 2 chloride. You have to tell me it's nickel 2+, rather than nickel 1+, because the chlorine, there's 2 of them. They're both 2 minuses. Okay, not dichlorine or dichloride, because again, this is an ionic compound. You only use monoditri for molecular compounds. D, xenon tetrafluoride. Xenon is a nonmetal. Fluorine is a nonmetal. You have nonmetal, so tetra for 4. Okay, does that make sense? N2O, dinitrogen monoxide. You have to have the mono because the O comes second. Okay, last one is the tough one. Al is aluminum. That one is easy. What is that monster? That's a polyatomic ion called dichromate. Yeah, that one looks intimidating, but actually the name is really simple. Aluminum dichromate. Now, that one is funny because di. Didn't I just say you only use monoditri for ionic, covalent compounds, not ionic? But for F, that's ionic because aluminum is a positive ion. Dichromate is a negative ion. Why the di? Why not aluminum chromate? Here's why. This di is not a prefix. That di is part of the name of the polyatomic ion. The Cr2O7, this ion's name is dichromate. Okay, I didn't put a di in front of it. It came with the name. So I felt like I had to explain that. Otherwise, you might get confused. That di is not a prefix. It's part of the name. You see what I mean? Okay, so I don't know how many you got right, but you do need a lot of practice, and practice will make you do this a lot faster with more confidence, with higher accuracy. Okay, so that's it. We're done for this lesson. We learned about molecules, molecular compounds, and covalent bonds. Okay, nonmetal, they share electrons for a covalent bond. You name them using prefixes. So, do we have any questions before I end this?